It does. All of these will actually work out.
So 1 equals 1, and 1 plus 2 is equal to 1 plus 2.
Or if A equals 1, then A plus 2 equals 1 plus 2. Alright, so go ahead and start copying these properties down here onto your notes. Okay? These are properties, at least the first 6 of them are properties that you've seen before. Okay? These are how we solve equations, right? Using these properties. Okay? These are just saying, well, if I have an equation, I can add the same thing to both sides. I can subtract the same thing from both sides. I can multiply both sides by the same thing. I can divide both sides by the same thing. Right? And then the distributive property. Right? You guys know how to use the distributive property. And then substitution. Okay? We can replace different elements in an equation if I know they're equal. Okay? So copy those down real quick here. Okay? You've used these before. Okay? You just never used them to prove something. Which is what we're going to start doing today. The last 3 of these, okay, reflexive property, symmetric property, and transitive property, might be new. I don't know if you guys have seen those before. Right. Yeah, I've seen some yeses and some nos. All right. So these are, and they seem like common sense, okay, but they're actually going to be very useful when we start proving geometric ideas. Okay? They're not going to be so useful today when we're talking about proving algebraic ideas, but once we get into geometric proofs, these 3 will be very useful. Okay? The reflexive property is just something is equal to itself. Right? That sounds even too common sense to write down, right? Like that's something is equal to itself, but that ends up being really useful when we start proving things congruent to each other. The symmetric property just says I can flip things across an equal sign. Right? If x equals 4, then 4 equals x. Right? Again, that seems pretty common sense, but it will actually be useful. And the transitive property, if I've got a equal to b, okay, and then b equals c, right? Or x equals 4 and 4 equals y, then I can say that x is equal to y. Okay? Or in this case, a is equal to c. If 2 things are equal to the same thing, then they're equal to each other. Does everybody have those copied down? Right. So what we're going to do today then, not that one, okay, is start using 2-column proofs. Okay, start using 2-column proofs. So today, hopefully, will be fairly straightforward. Okay, but this is the same format we're going to use once we start getting to geometric proofs. So we're going to introduce it with algebraic ideas that you already know how to do. Okay, and then we'll get into geometric stuff. So on the left side of a 2-column proof, we're going to list the statements. Okay, the statements. So in our algebraic proofs that we're going to do today, our statements are just going to be the steps of the equation. And then on the right side, we're going to list the reasons. Okay, so we can use, okay, really the only things we're going to use today, okay, everything we listed up top is called a property. Okay, so we can use properties, but we, again, once we start getting into geometric proofs, we'll start using things like theorems, postulates, Properties, postulates, and definitions. All right, so what this is going to look like for today, okay, we're just going to solve an equation on the left side of our proof, and then give a reason for each step, okay, a property from our list up top that allows us to do that. So the first couple examples on here, the equation is solved for us. We're just going to fill in the reasons, okay? Now, the first line in a proof is always the given information, okay? So for today, we're just going to write the problem down in the first line, and that's going to be our given information, right? So then we want to think, well, what did I do to get from step 1 to step 2? I added 1 to both sides, right? So up top, that what would we call that to be technical? The addition property of equality, right? This marker's about to, okay, so give me another black marker out of the top drawer. No. Okay, so now, what did I do to go from step 2 to step 3? Yeah, I divided both sides by 4, so we would say the division property of equality. Okay, so all we're doing here is looking, okay, for these first few examples, looking to see what they did to go from step 1 to step 2. Okay, and then figuring out our justification. Questions so far? All right, let's take a look at the next one. Okay, actually, why don't you guys try the next 2? Okay, numbers 2 and 3 here. We will look at properties of congruence. Yeah, so yes, it's not going to kill your wrist too much. Can't feel it. I guess, yeah, I did make these kind of small. Right, so try numbers 2 and 3 here. I mean, you guys can talk about your answers as you're working here. Compare, make sure you guys are getting the same things. So we get something like this. Right. Subtraction and multiplication for number 2. And for number 3, distributive, then subtraction, then division. Questions? Alright, so then let's jump over to the back here. Okay, we don't need to do the rest of those. Okay, on the back, we have to do the whole thing ourselves. Right? We're not given the statements. Okay, so we have to solve the equation and also write in our reasons. Okay, so what should our first statement always be? Rewrite the equation. Right? So number 1 here, 3x plus 1 equals negative 14. And my reason is given. Okay, now in each of these problems, they also tell you the answer. Right? They tell you what your final thing should be. So I can go ahead and fill in the last line as well. Right? I don't know the reason yet, but I know that my last line is going to be x equals negative 5. Yeah, we will. Well, you're right. There are only 2 steps. Okay, so but our first line is the given. So then our second line, we would subtract 1 over, right? So, and I mean, you can write in what you're actually doing. Okay, and so then this would become 3x equals negative 15. What would my reason be for that? As subtraction property of equality. Okay, and then what would I do? Divide. So, yeah, I guess once we divide here, we just get x equals negative 5, right? So yeah, I guess there is one too many lines. Right. So we said we're dividing, right? So that's the division property. Yeah, I don't know why they have an extra line. Alright. We okay with this process? Okay, so solving the equation and then justifying each step on the right side. Okay, so let's just go ahead and practice some of these now. Alright. We've got 16 minutes, so we should be able to get through a decent number of these here. So you guys can work on these together. Share your thoughts with each other. Okay, if you have questions, ask me. Quick, talk about number 5. Okay, I'm guessing I probably did this different than most of you, and I did that on purpose. Okay, I'm guessing most of you subtracted the 2k over. Okay, well I subtracted the 10k over, right? Just to show that for a lot of these, there's more than one right answer. Okay? There's not one way to write a correct proof. Okay? And that's going to be even more important when we get into the geometric ones. Okay? You're given some information at the beginning and asked to prove something at the end. Right? There's not one set way to get there. Right? You're just going to use what you know. For today, we're talking about using our knowledge of solving equations to get to the end. Okay? You guys probably subtracted 2k over. Okay? Well, I subtracted the 10k over, but we both got to the same place. Right? Now, another actual technicality here, right, that I want to talk about is I did not get what they told me to prove. They told me to prove k equals negative 2. I got negative 2 equals k. Okay? technically that's not this, right? Technically, I would actually have one more line here, okay? What property allows me to switch things across the equal sign? A symmetric property, right? So technically here, I should say k equals -2 by the symmetric property, right? So just one small technicality there. Like,
The last one is
no, I mean, again, like you may have done it differently than they had originally thought, but that, as long as you get to the answer at the end, that's fine. And I mean, you know, at number 5 here, technically I needed one more line. Yeah, so